We're looking forward to the launch of Hera this week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. Happy Launchtober, everyone, and happy World Space Week. Over the next few weeks, we'll be covering the highly anticipated launches of the European Space Agency's Hera mission and NASA's Europa Clipper mission. We have so much to look forward to in the coming weeks in space. We'll start today with a conversation about all things Hera with Michael Küppers, Hera project scientist. Then Ambre Trujillo, our digital community manager at the Planetary Society, will let you know how you can celebrate Europa Clipper by joining NASA's Runway to Jupiter style challenge. We'll close out with Bruce Betts, our chief scientist, as we discuss the potential future meteor shower caused by the DART impact in What's Up. It's also the first week of the month, and you know what that means. It's time for our monthly space policy edition of Planetary Radio. As the United States approaches the upcoming presidential election, Casey Dreyer, our chief of space policy, delves into what the election could mean for space. Last month, he spoke with Greg Autry, who served on Trump's NASA transition team in 2016. This month, Casey interviews Lori Garver, who served on NASA's presidential transition teams for Clinton and Obama. She'll let us know what a potential Harris administration would mean for space exploration. You can catch our upcoming Space Policy Edition on Friday, February 4th. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. I can't believe it's time. It is officially Launchtober. Space fans all over the world have been eagerly anticipating the launch of the European Space Agency's Hera mission to the Dimorphos asteroid system and NASA's Europa Clipper mission to investigate an ocean moon of Jupiter. Coming up first, on October 7th, is the launch of ESA's Hera mission. It's a direct follow-up to NASA's Double Asteroid Redirection Test, or DART mission. The DART spacecraft, which launched in 2021, had a relatively straightforward but critical goal: to test the kinetic impactor method for deflecting asteroids. Essentially, they slammed a spacecraft into an asteroid to see if they could change the object's trajectory, and it was a smashing success. DART's target was Dimorphos, a small moonlet orbiting an asteroid called Didymos. In September 2022, DART made a dramatic impact, successfully altering Dimorphos' orbital period around Didymos and making history. And now that the debris from the blast is mostly cleared, ESA's Hera mission is set to head back to the system to investigate. On October 7th, 2024, Hera will blast off from Cape Canaveral, Florida on a SpaceX Falcon 9 rocket. Hera is equipped with a comprehensive array of high-resolution visual, laser, and radio mapping instruments. These tools will let the spacecraft do a thorough investigation of the impact's aftermath, including a careful analysis of the DART impact crater, measurements of Dimorphos' mass, and tracking of the orbital changes. Fans of the DART mission may remember that it released a CubeSat before the impact, the Italian Space Agency's Licia Cube. The upcoming Hera mission is going to build on that success by deploying two CubeSats named Milani and Juventas. Part of what we do here at the Planetary Society is advocate for and support planetary defense missions. While the threat of an asteroid impact is statistically small, it's still serious. Our intelligence as a species has given us many gifts, but one of them is that humanity actually has the chance to prevent that kind of large-scale disaster and save all of the creatures on Earth. All we have to do is take steps to track, characterize, and deflect incoming near-Earth objects. Missions like DART and Hera are crucial in helping us make this happen. Our guest today is Dr. Michael Küppers, project scientist for ESA's Hera mission. Michael is a planetary scientist who focuses primarily on researching the physics of small bodies in our solar system. That includes comets and asteroids. He spent more than a decade working on ESA's Rosetta mission. That was the first spacecraft to rendezvous with a comet and follow it in its orbit around the sun. Now Michael is applying that expertise to Hera and to planetary defense. With less than a week to go until the big day, Michael and the rest of the Hera team are preparing for the launch. Hi, Michael. Thanks for joining us.
Hi, good afternoon.
Congratulations on this upcoming launch. This has got to be really exciting.
Wait with the congratulations for afterwards.
I know, right? and I should mention, too, that this launch is scheduled for some time between October 7th and the 27th, but we're in the middle, as we record this, of a hurricane in Florida, Hurricane Helene. So I want to send my well wishes to everyone who's impacted, as well as any members of your team that might be on the ground right now setting up for the mission.
Yes, indeed. We have the hope, and there seems to be some indication that the hurricane is moving away. So we are still in good spirit for the launch.
For those who are unfamiliar with Hera, we've spoken a lot about the DART launch in the past, but this is the follow-on mission. Can you tell us a little bit about the primary goals for Hera?
Yeah, indeed. So DART has successfully impacted Dimorphos, the moon of asteroid Didymos, 2 years ago. And now we are launching Hera, which will need another years to get there, to then in late 26 and 27 investigate what exactly has happened during the DART impact. So one goal is to measure the mass of Dimorphos, which we need to understand how efficient the impact was. Another goal is to look at the exact outcome of the impact. So was a crater formed, or was the impact stronger that really it became so big that the whole moon, the whole Dimorphos was deformed by the impact? And the third goal is to generally investigate the two asteroids to essentially be able to extrapolate the results to another asteroid should we need it one day to save Earth.
The papers I've read so far and the previous conversations I've had with people from DART seem to indicate that this last impact completely changed the shape of this object. So getting a close-up look at what actually happened here is going to be just fundamental.
Indeed, we do have some evidence that the shape of Dimorphos may have changed, and it's indeed now essential to see what exactly happened.
So when the DART impact actually happened, we monitored it not only up close with the Italian Space Agency's Licia Cube, but also with space telescopes and telescopes all over the world. What is it about getting up close with the system with Hera that we can't learn from the ground?
One thing we can't learn from the ground is what happened to Dimorphos itself. From the ground, Didymos, the main asteroid, and the Dimorphos, the moon, are just 1 point of light. So a change in the shape or in the rotation state of Dimorphos is not possible to derive from the ground-based observations in a unique way. This is where we need another mission.
And as with so many wonderful missions, this kind of evolved out of an earlier mission concept, in this case, the Don Quixote kinetic impactor from the early 2000s. How did that become Hera? And how did that end up as a collaboration between the United States and ESA?
Actually, Don Quixote was before my time, but around 2000, the idea started of a planetary defense demonstration, which is quite similar to what now happened with DART and Hera. In a sense, there was one impacting spacecraft and one observing spacecraft. At the time, it was foreseen to slightly modify the heliocentric orbit of an asteroid. Then Don Quixote didn't really receive funding. It was, in a sense, a little bit ahead of its time. At the time, there was no Planetary Defense Office and ESA, and it didn't really fit in the existing program. So at the end, there was really no funding for it. So it didn't materialize. And then a couple of years later, APL came up with the specific idea to do the same, but on a binary asteroid. So the advantage is mainly that you need a smaller impact, let's say, to measurably change the orbit of an asteroid moon around the main asteroid. Then you would need to change the heliocentric orbit of an asteroid. And when this idea came up, the colleagues contacted ESA for possible collaboration. And from this came first DART and AIM. So at the time, the asteroid impact mission was proposed to arrive before the DART impact and to monitor what's going on there. In the ESA ministerial conference in 2016, AIM raised a lot of interest, but not sufficient funding. But because of the interest, the study was continued, and in the slightly modified form of Hera, it was then approved in 2019 and will now be launched in October this year.
I love, too, that in tribute to Professor Milani, who came up with this idea from the University of Pisa in Italy, you named one of the CubeSats after this professor. That's such a sweet thing to do.
Yeah, that's right, indeed. As you said, one of the, let's say, founding fathers of all this was Professor Andrea Milani at University of Pisa, who unfortunately passed away in an accident a few years ago. And so the Hera team decided to name, yes, one of the CubeSats after him.
It's beautiful seeing the legacy there. I wanted to mention, too, that we're coming up on the 10th anniversary of ESA's Rosetta mission to Comet Churyumov-Gerasimenko, and you worked on that mission for, what, almost 15 years?
Yeah, I was involved in that mission for a long time, yes. around 15 years or so.
What's interesting about this is that we have so few examples of these small bodies that we've ever been able to go up to, let alone land on. I'm sure there's a lot of lessons we can take from the Philae lander and Rosetta's landing on Chury that we can then apply to this new mission.
That's true. Indeed, the concept of the operations around the asteroids with Hera is essentially borrowed from Rosetta. So the whole concept of the hyperbolic arcs with first an what we call early characterization phase from some distance to get the global properties of the asteroids, and then getting closer and closer, and to finish up with close flybys and then landing. This whole concept is pretty much taken over from what was done on Rosetta.
Although we've seen with other missions that have tried to not even land on asteroids, but just touch the surface, that it creates all kinds of ejecta, or in the case of OSIRIS-REx, it almost swallowed the whole spacecraft. Yeah. So it's going to be a really interesting challenge to try to land something on this.
Absolutely. And I have to say, our success criteria would also not be the usual success criteria, because you also have to consider our CubeSats are essentially just small boxes. They are not dedicated landers. So if they land and bounce back and go away into space, I think it would still be a success. We would learn a lot from the fact and also from the way they interact with the surface. So in this sense, our success criteria, I mean, if they stay would be and continue operating would be absolutely marvelous, but we cannot necessarily expect that is going to happen.
I really hope it does, though, because each of these CubeSats are kind of on separate missions, but Juventas specifically, I think, is supposed to be mapping the interior of Dimorphos. And I want to know what's going on there, what's going on in the interior, how that was changed by the impact. That's some science I'd really like to see done.
Yeah. Now, Juventas, indeed, it's the first time that we carry a radar to an asteroid. And Juventas, actually from orbit, Juventas will investigate the interior. It's different from the Rosetta radar, which was essentially a ping pong between orbiter and lander. Hera carries a monostatic radar that essentially measures the reflected signal from the asteroid. So this will be done while Juventas is in orbit.
What is Milani, the other CubeSat, going to be doing?
The main instrument of Milani is a visible and near-infrared imaging spectrometer. So the main goal there is the surface composition and the surface properties you can get from spectroscopy and from imaging, also at various phase angles.
It's going to take a little while for the Hera mission to actually reach the system. What kind of orbit is it going to be taking on once it gets there?
Once it gets at the asteroid, it will, because the asteroids are so small, Kepler orbits would not be stable and would need lots of corrections. So what is done are hyperbolic arcs. Essentially, you are continuously above the escape velocity, which is 40 centimeters per second for the system at the closest, and make a maneuver every 3 to 4 days to get back to the asteroid. And you fly these arcs to get some global coverage of the asteroids. And once you have the shape, the mass, and so on, you then essentially first repeat the same nearby. In that process, also the CubeSats are released. And then the 3 spacecraft are operating there independently. And at some point, we switch from these arcs to flybys, which are essentially straight lines, and they get closer and closer to the surface. You want to go down to less than a kilometer from Dimorphos. And similar, these flybys, of course, with spacecraft maneuvers, they are inverted to stay in the environment of the asteroids. And
then once this spacecraft actually reaches there, it goes into orbital insertion, how long is the mission going to be in operation?
Nominally, the mission will be in operation for 6 months.
That's not a whole lot of time, but at the same time, it's probably enough to see what happened there, considering, I hope.
It's hopefully enough to see what happens there if everything goes well, yes.
What kind of data are we going to be getting back from these spacecraft?
So for being relatively small missions, we have a lot of payloads there. The main spacecraft carries cameras, what we call asteroid framing cameras, who are getting images both for the autonomous navigation and for science or for planetary defense. We also have an imaging spectrometer that works in the range roughly 650 to 950 nanometers. A thermal infrared imager in the 10 micron regions that is contributed by the Japanese aerospace agency JAXA, and a laser that is also both used for scientific measurements of the surface and for navigation.
What kind of resolution are we going to get on the surface features of this thing?
So from the characterization orbit at 10 kilometers, we get about 1 meter per pixel resolution, and correspondingly, when we have a close flyby at 1 kilometer, we go down to 10 centimeters.
In the case of OSIRIS-REx at Bennu, we ended up with a beautiful kind of 3D rendering of that object. Are we going to get something similar for Dimorphos?
I hope so, yes. So yes, I mean, we will, of course, of the images that are being taken from essentially all three spacecraft, we will create shape models of the asteroids, and this can also be then used for 3D renderings.
I hope so. And 3D print it and add it to my collection of small bodies I have on my desk. Yeah. I actually have one of a Comet Chudermov Gerasimiko on my desk that was, I think, left over from the time that Emily Lakdawalla worked at the Planetary Society. We're going to end up with the spacecraft looking at this object. Do you think we're actually going to be able to see fresh, unweathered material from the start impact?
Possibly, yes. So especially I could imagine that we see fresh unweathered material on Didymos. Mm-hmm. The material essentially that left Dimorphos, that landed on Didymos, and also even of Dimorphos itself, if you get material from the subsurface, it could be or should be somewhat different from the usual surface material.
I hope so. I mean,
I hope so, yes.
A lot of this is about learning more about planetary defense, but I think part of the mission that a lot of people aren't giving it credit for is that this is an opportunity for us to kind of learn a lot about the foundational building blocks of our solar system, essentially, by looking at this material.
Absolutely, yes, absolutely. Asteroids and comets are the building blocks of the solar system, essentially. The small bodies that the planets are made of, or they are the leftovers, those that haven't found a planet in the origin of the solar system and now are still around and tell us exactly how the conditions of the formation were. And also, it's the first mission to a binary asteroid, so we also hope that we will learn a lot about how those binaries formed.
That is a really interesting thing because, we've seen this system. We saw during one of the earlier Lucy mission tests, they flew by an object that turned out to be a binary asteroid. I mean, we only have so many examples, but I think if I'm remembering correctly, it was something like 15% of all small body systems are binary asteroids. Is that right?
Yeah. That's right. And I would consider that maybe a lower limit in the sense that not all those binary systems are detected from ground.
Yeah,
at least both. The very first one, Ida, the satellite of Ida was detected by a spacecraft, and now Dinkelnish also was identified as a binary from ground-based observations. So you can speculate that there may even be significantly more than 15% that are actually binary asteroids.
It's pretty funny that we keep being surprised by these, but given the difficulty, I mean, all you really have is light curves and things like that to try to tell you what these things are like, or maybe radar.
Yes, nowadays a lot of them with light curves, with radar, and also now with Gaia, also with astrometry. But it's still the case that those techniques are not sensitive to all types of possible binaries.
How does the system compare in kind of mass to those other binaries? And will it actually allow us to kind of extrapolate out what we can know about other binary systems?
So I would say that the Didymos system is kind of a typical binary in terms of the separation and size ratio and so on for binaries of small near-Earth asteroids. So in that sense, I would say we could probably learn something more globally from understanding how that system formed.
A lot of what I've read online suggests that we think kind of the reason we end up with these binaries could be because of this kind of Yarkovsky effect, right? A larger object gets kind of spun up by the light of the sun.
The York effect, yes.
Yeah.
This is one thing that exactly, that the York effect spins it up and then material is shed and forms a binary. Another possibility are impacts, either directly from the impact ejector, or the other option is that the impact leads to a spin up above the highest, faster than the cohesion limit, and that the formation of the binary comes from that.
This system spends about, I think it was like 1/3 of its time in the asteroid belt, where it's kind of,
Indeed.
More dense. So what are
Yes.
the odds that this thing has been hit by objects the size of DART before?
It has been hit by objects the size of DART before. I mean, with DART, it was difficult to identify craters. There are a couple of potentially identified craters, but this may be indeed because we are also not sure if the DART impact created a crater or more deformed the object, but just taking the statistics of impact rates and cratering and the lifetime of Didymos or Didymos and Dimorphos, it's highly likely that DART-sized impacts have happened before.
And by comparing the cratering on not just Dimorphos, but also Didymos, I bet we can get a better understanding of how this impacts these things over time. I'm really curious to figure out how we can kind of disentangle the Yorp effect from it being pummeled by objects in the asteroid belt to actually figure out the history of this thing.
Yeah, this is indeed true. I mean, there's now a newer publication that says that in the case of Didymos, which, as you said, spends 1/3 of the time in the main belt, impacts are probably more important than the Yorp effect, also because of the possible spin up due to impacts. And one other aspect of this is, I mean, all the age determination, because one point is also to find out how long the object has been in this orbit. And for the age determination, we use a cratering record. And here we have also the unique opportunity that we investigate, a crater or the impact outcome, let's say, for something where we exactly know the impactor. With DART, we know exactly the impactor, its size, its mass, its velocity, which helps us a lot to improve our crater scaling. So essentially to say which impactor on such an object creates which kind of impact outcome, and therefore also to improve all those models that are connected to the impacts.
When we hit it with DART, the ejecta was just, at least personally, so much more than I expected. That thing was beautiful.
Indeed. Yes.
How big of a cloud did we kind of create, and how long did it hang around after the actual impact?
Okay, it hung around for several months. Also, the extended cloud was seen by ground-based and observers and HST for several months after the impact. Size, I don't like here to specify size because it's a cloud that is expanding into space. It doesn't really have a boundary in that sense.
Is there any concern that any of this ejected material is still close enough around that it might in some way harm the spacecraft?
So any small material by the time Hera will have been pushed away by radiation pressure. It is possible that a small fraction of larger blocks maybe get into stable orbits for years and may also still be present when Hera arrives. I'm personally not worried about that simply from scaling from Rosetta. I mean, Rosetta operated for 2 years around an active comet, and collision with things was never a problem. That Rosetta had to back away for some time was essentially because of dust confusing the star trackers. So about some boulders being around with Hera, I'm not worried. And I think the background is that in such a situation, we intuitively tend to overestimate the collision probability.
Yeah, fingers crossed.
Yeah.
Oh, man. I did read, too, that we hit that thing so hard that there's a chance that we might actually see meteor showers caused by this object, either on Mars, but also potentially on Earth. Were you one of the people that created that? If I'm remembering correctly, you were on that research.
Yes.
If that does happen, how would we determine whether or not the meteor shower that we see is caused by the DART impact?
From the numerical model, we can relatively precisely say from which directions the meteors would be coming. In time, they are much more distributed. We cannot predict a specific date. We can just provide it some time spans where we could see some enhancement. Now, to limit expectations, I wouldn't expect a meteor shower like the Perseids. We would really be looking for an enhancement in that direction of the sky at certain times.
It occurs to me that between DART and all of these other objects that have hit these things in the past, that there is a potential that Dimorphos might not last forever if it keeps getting blown apart by these things, at least if it's a rubble pile enough. Is that possible that it might get blown apart over time?
Absolutely. I mean, at some point in time, either Dimorphos or Didymos, I'm not sure which has a higher lifetime statistically, will be hit by something that's destroyed it. I mean, those kind of impacts were also that led to the formation of what's now Didymos and Dimorphos from some larger objects. Basically, all asteroids smaller than 100 kilometers or so are the result of fragmentation and reaccumulation, and they're not original objects in that sense.
But who knows? Maybe it'll create a new one after it gets blown apart. Or
yeah, absolutely, yeah.
Maybe the material might just fall back onto Didymos.
I guess if now Dimorphos is destroyed by an impact, probably part of the material will escape and part will fall back on Didymos. Mm-hmm. And if in case Didymos is hit by something large, maybe it will form another moon.
That would be cool.
Several decades ago, the general opinion was that asteroids cannot have moons.
It's funny how wrong we've gotten so much of this. It's just the beginning of understanding this, which is a really interesting thing to think. I feel like so many people want to believe that we have a good handle on what's going on with asteroids and planetary defense, but we're just taking our first baby steps.
Yeah, I mean, planetary defense DART and Hera are really the first technology demonstration for planetary defense. So in that sense, we are at the beginning.
Yeah, the DART mission was actually my first rocket launch that I got to go see. I drove out to...
Mine as well. Was
really?
Also the first launch that I saw, yes.
That's amazing. Are you going to be in Florida to see Hera go up?
Yes, I also be. That will be the second one for me. And I'm flying next Friday to Florida for that, yes.
Do you get to stick around to try to see Europa Clipper launch afterwards?
Yes, I'm going to try to see Europa Clipper as well, yes.
Oh, I'm jealous. That's going to be so cool. So many of my colleagues get to be there for Europa Clipper, and I hope so much that both of these missions go well. That's going to be such an adventure. Yeah. So we're potentially going to get 3D models out of this thing, but are there any onboard cameras that are going to give us some really spectacular imagery that we'll be able to look at online?
Yes, of course. We will. The images will be distributed. We have an open data policy, so you can see will be able relatively soon to see the images of the asteroids. And we also have the cameras on the CubeSats, and we have the so-called small monitoring cameras on Hera that will image the release of the CubeSats.
That's going to be really cool. Will the CubeSats be able to image Hera, like back and actually see the spacecraft?
That's a good question. I'm not sure at which distance this could be done and what would the resolution be, but we should definitely try that.
That'd be so cool, because anytime we get an image of a spacecraft in space from the CubeSats, it's always one of the most iconic images I've ever seen. The fact that we're doing this at all is just absolutely mind-blowing.
Yeah, and actually, and there's one reason also for the small monitoring cameras the other way around. It may be difficult after release, well after release, because the CubeSats are so small.
So something that I'm really looking forward to in this case, I guess, is actually seeing the images of the impact site. What are some of the things that you're most looking forward to?
Indeed, seeing how Dimorphos looks like now, how the site that DART saw looks like now, and also how the other side looks now that DART and Lichia could not see.
Yeah, because we zoomed up on that thing and then literally crashed into it. So it's not like we've got a lot of time to see both sides. I mean, we're going to try to discern how this thing was, changed just from the front side of Dimorphos. But I mean, there's so much we don't know about what this thing looks like.
Yeah. I mean, we don't really know how the backside, so to speak, looked before the impact. But already seeing the changes on the front side will be interesting.
We'll be right back with the rest of my interview with Michael Küppers, project scientist for ESA's Hera mission, after this short break.
Greetings, Bill Nye here. NASA's budget just had the largest downturn in 15 years, which means we need your help. The U.S. Congress approves NASA's annual budget, and with your support, we promote missions to space by keeping every member of Congress and their staff informed about the benefits of a robust space program. We want Congress to know that space exploration ensures our nation's goals in workforce technology, international relations, and space science. Unfortunately, because of decreases in the NASA budget, layoffs have begun. Important missions are being delayed, some indefinitely. That's where you come in. Join our mission as a space advocate by making a gift today. Right now, when you donate, your gift will be matched up to $75,000 thanks to a generous Planetary Society member. With your support, we can make sure every representative and senator in D.C. understands why NASA is a critical part of U.S. national policy. With the challenges NASA is facing, we need to make this investment today. So make your gift at planetary.org/takeaction. Thank you.
Did you get to go to a party or anything to actually watch the DART impact? Because I know some of my colleagues did. Yeah?
Actually, yes, I was at APL for the DART impact at the event there.
Oh, that's wonderful. You were probably there with some of my coworkers. That's so funny.
Yeah, probably.
What was that like? I mean, for me, watching it online, what was
really spectacular for that is that it was transferred practically in real time. I mean, essentially, the data was streamed as they came from the spacecraft, and you could, in that sense, see the impact. I mean, not the impact itself, but the images when that approach to the impact. That was really spectacular.
Yeah, that moment when the screen tried to give us an image, but it was like half an image, the other half was all red and messed up.
Yes. And also before this extreme detail, and you knew that you knew, of course, it would be end, but it was really, the whole time from actually seeing the asteroids and seeing Dimorphos for the first time to getting closer, and then it was really spectacular to be able to see this in real time.
That was such a party to witness online and from afar. Is your team doing anything? I mean, fingers crossed, hopefully everything goes well with the launch of this mission. What is your team going to do to celebrate after the mission successfully launches?
Okay, I have to say first give credit to my colleagues in the operations center who have to work after the mission successfully launched.
Yeah.
But we will have the celebration with a dinner party at Kennedy Space Center with those who do not have to work on the operations.
Oh, you're going to have such a treat. I only got to go there once, but it was for the Artemis 1 launch that didn't happen. And despite the fact that the launch didn't happen, that place was so cool. It was absolutely worth doing anyway. So this thing it hasn't gone up yet. What are the last steps that everyone has to take for preparation for this launch?
So the very last step, I think fueling of the spacecraft is finishing today. And then I don't know the exact setup, but then essentially it is fixed to the rocket, rolled out to the launch pad, where it now has to wait first of the Crew 9 launch going into space.
What would you say that this mission could do for the future of planetary defense?
I think it is the first time that with DART we have demonstrated the method, and with Hera we know the quantitative outcome, which helps us really for the future to not only to repeat it, but kind of also to scale what size of impactor you need for a given target.
How did you originally get into this field? I mean, given your history, you went and worked on the Rosetta mission and now this. How did you become so passionate about small bodies and planetary defense?
I'm a planetary scientist by education. And I relatively early on, among other things, I did start working on asteroids and comets, both observationally and also a bit modeling. And in 2003, I started working in the camera team on the science camera team of the Rosetta missions, and a couple of years later, I moved to ESA and became involved there. And so, this brought me really close to the space mission, and this is a fascinating topic, and I stick with that.
Just imagine one of these days if we actually save the world using the science that was created from this. You'll be able to look back and think to yourself, "Well, I helped save the planet."
I helped save the planet.
And, oh man, especially I think of the missions that are out there, I think the Rosetta mission is definitely one of my favorites, just for the imagery that came out of it. This kind of alien world, the way that the kind of dust and the kind of it was beautiful.
Yeah, for me, I'm biased because I've worked on the mission for a long time. But yes, for me also, Rosetta was really maybe the most fascinating missions with also they're seeing more and more detail when you arrive, and then this long time at the comet, and the comet, even better than an asteroid, you can see the changes in real time, in quotes, how the comet changes due to its activity, and feel a landing. And yes, it was really spectacular.
I got really emotional near the end of that mission when Rosetta found Philae again. Yeah. I remember that situation, which who knows if there will be a similar situation with one of the CubeSats here where it tried to land and then bounced and we couldn't find it.
Yes, could be, yes.
But is there a similarity there as well in that at the end of the Rosetta mission, the spacecraft tried to land on the comet? Is that what we're planning for the end of the Hera mission as well?
Possibly, yes. I mean, we have for definitively we are trying to land Juventas on Dimorphos, and most likely we are going to land Milani either on Dimorphos or on Didymos. For Hera itself, it's not yet finally decided, but an option is also landing at end of mission.
But what's going to dictate which of the two objects Milani tries to land on?
Okay, the argument is for Dimorphos would be that if you want Dimorphos as a planetary defense target and Hera as a planetary defense mission. And the other thing is, of course, the instrumentation is complementary. So for Juventas, the main thing would be after landing to use the gravimeter to get the exact, essentially the three-dimensional accelerations and an exact grab on the gravimetry, maybe also on the mass distribution of the object. For Milani, the interest would be more on the dust detector to get maybe more material, essentially more information about the dust from the dust that would be moved up at landing.
And are there any difficulties in trying to orbit a binary system specifically that we don't really have to deal with in other cases?
It's more complex to orbit a binary system than orbiting a single asteroid. At the same time, I think this difficulty kicks in relatively close to the objects because globally more than 99% of the mass of the binary asteroid is in Didymos. So if you are significantly further away than the separation between the two, it shouldn't matter that much that it's a binary. But I think the other aspect is that most binary asteroids have been detected relatively recently, which is the reason that for example, the NEAR mission went to Eros in 2000. One thing is that Eros is a relatively large asteroid, and in near Earth space, we don't have a binary at that site. But also when this mission was planned, not many binary asteroids were known. So the other reason is that the binary asteroids themselves are relatively recent discovery.
I think you're probably right that we're going to learn that this is actually kind of the lower bound of how many of these there are. Like, given that we keep stumbling upon them, I wouldn't be surprised if there are a lot more than we anticipate.
Yes, I also would personally expect that we will be somewhat beyond the 15% currently. That is what we get from the ground-based observations.
Have you been able to go to the Planetary Defense Conference before?
Yes, I have been there twice, I think, yes. It's an interesting thing, this impact exercise that's happening there usually. And it's, yes, it's something good to do also, the planning. What would you do if it happens, essentially?
Yeah. I mean, this is a truly international problem. It affects every single one of us, even though it's a rare thing. It's something that could potentially harm everyone on Earth. And so seeing the interplay between NASA and the DART mission and ESA and the Hera mission and the international friendship and collaboration that comes along with that, I think is really exemplary of this idea that it's something that impacts all of us. And that's part of what's so special about space exploration is that it creates these bonds across nations that allows us to really collaborate in a meaningful way.
Absolutely. It's it's an international strategy, and also it's an international endeavor with most international space agencies involved in the planetary defense activities.
I'm I'm so grateful because as a child, I know it was movies like Armageddon and Deep Impact that scared
Yes.
me, but I was very, very concerned that humanity wasn't doing enough to protect the people of Earth and all the creatures from this inevitable potential that we're going to be hit by something at some point. And it feels like we're finally being able to get a handle on this. Like this is the beginning of us being able to save the world.
Yeah, I agree with that. I mean, I personally am not really worried. I mean, simply because I know I will be within the next, several decades, I will die at some point, and an asteroid impact is an extremely unlikely reason to be the reason for that. But it's true. It's a danger that as humankind we can now, or we think we are now on the way that we will be able to prevent it. And I think we should prepare, and we should be able to prevent it, to be prepared for the next time it happens. And those things that are outside our, let's say, our experience, it's sometimes difficult to really consider and to really convince also that this needs prevention, or that it is useful to do planetary defense. In this respect, I like to compare it to the pandemic, which is another thing that is not happening. That's frequently it's outside our experience. And also I've been talking like this about planetary defense for years now. I also wasn't prepared or aware of that I should be prepared for a pandemic. I think for those things, it's a bit in human nature that we don't worry about things that are outside our everyday experience.
Mm-hmm. But in the event that rare occasion happens, we have scientists all around the world that are laying the plans in order to deal with something like this.
Absolutely, yeah.
Well, what do you think you're going to feel when it actually gets off the ground after all of this effort?
I don't know. I will probably be a bit nervous, but also very happy to see it actually going into space.
Well, I know I'll be watching. Are there any live streams online where people can watch Hera launch?
Yes, I believe Hera launch will be live streamed both by SpaceX and also by ESA TV.
Wonderful. Well, we'll share that live stream online at planetary.org/live so people can watch. But if there are any Planetary Society members listening, please join us for a watch party inside of our member community, because there's nothing like sharing these moments in space with other space fans that have been anticipating them for years. So I'm looking forward to watching that with everyone online.
Yeah, that's great.
Well, good luck to you and to all of the members of the team. And I hope you have a really fun time in Florida just watching these launches. There's nothing like being there at Cape Canaveral for this with the huge audience around you. You're going to have the best time ever. Well, good luck to you and everyone on the team. And I'm hoping in the future that after the launch happens, fingers crossed, everything goes great. I'd love to bring a member of the team back on to talk about reflections of how it went and how it felt to see this.
We're happy to talk about that, yes. And
awesome.
How it goes with the first observations after launch, yes.
Oh, absolutely. Definitely bringing everyone back on once we get those first images. That's going to be a huge moment.
Yes.
Awesome. Well, thank you so much, Michael. Good luck.
Okay, thanks to you.
As I said in the interview, the Planetary Society is holding an online watch party for the Hera launch in our member community app. The launch is scheduled for October 7th at 10:45 a.m. Eastern Time. That's 7:45 a.m. Pacific Time or 14:45 UTC. We'll share the launch live stream at planetary.org/live so anyone can watch. If you're a Planetary Society member, you can join me and my colleagues in the watch party chat and the rocket launch space in our community. We're also going to be holding a watch party for Europa Clipper just a few days later. That's on October 10th at 12:31 p.m. Eastern Time, which of course is 9:30 a.m. Pacific Time or 16:31 UTC. Keep in mind that all of these times may change. Rocket launch times vary depending on what's happening with the rocket or what's going down with the weather at the launch site, but this situation is a little more complex than usual. As I'm recording this, the U.S. Federal Aviation Administration has confirmed that SpaceX's Falcon 9 rockets are grounded because of issues during the Crew 9 launch over the weekend. We're hoping all is well and that the FAA will clear the missions for launch in the coming days. I'll leave a link with more information on that story on the show page for this episode of Planetary Radio if you want to learn more. But One of my friends and my favorite ways of celebrating launches is to dress for the occasion. Between Hera and Europa Clipper, it's time to pull out all those cool space ties and dresses. If you'd like to join in and show your space flair, you can consider joining NASA's Runway to Jupiter Style Challenge, celebrating the Europa Clipper launch. Here's Ambre Trujillo, our digital community manager, with the details. Hi, Amber.
Hey, Sarah.
The Europa Clipper launch is so soon, and I'm in this mode where I'm just kind of all nervous and excited. Are you feeling that too?
Oh my gosh, I am getting butterflies in my stomach just thinking about the launch. I'm so ready. I'm so ready to see this be on its way.
Right. And you're actually going to be in Florida for the launch, right?
Correct. Yeah, I'll be at Cape Canaveral, gearing up with a couple other staff here at the Planetary Society and some members. So we're turning it into a little bit of a member meet and greet, and it'll be a lot of fun.
It's great because my guest just now, Michael Küppers from the Hera mission, is also going to be there for the Europa Clipper launch. So who knows if you'll bump into each other, but either way, I feel like this is going to be one of those moments that all the space community around the world should be celebrating. And whenever I get really excited about one of these things, or I'm like at a space event, something that I like to do, and I know you like to do too, is kind of theme your outfits around space. Like, why do you feel like that's such a fun thing to do in those moments?
Oh gosh. So it's not only a fun thing, but it's a productive thing for me. I sometimes just don't know what to wear at conferences or these space events. And it really helps me creatively to be like, okay, what is the theme of this event or this conference? You know what I mean? So if it's about the Artemis program, I'll be like, okay, what grays do I have? What layers can I put into this in order to make this fun? And nobody else really knows that I'm doing that. It's just something that I do because it helps my brain just be like, pick an outfit.
Yeah, people can't see it because these are audio only recordings. But whenever I'm doing interviews with people, I'm always wearing some kind of jewelry or piece of clothing that kind of matches the theme. So I got a whole bunch of different space necklaces for all the different events. And I'll definitely be probably wearing my JWST Jupiter for this one.
Oh, wait, I love that. I had no idea. And I wish I was better with jewelry. I don't have like really any jewelry at all. And there's so many cool jewelry options out there. So maybe that's my next endeavor.
Yeah, something I did was I got magnetic swappable jewelry. I believe I got my two necklace sets from Sartorialist. They have this great necklace that you can just like swap out the space image. So I just change them.
Oh my gosh, that is brilliant. I have to look into that. Yeah, that sounds something that is definitely for me.
Well, it sounds like NASA's kind of caught on to the fact that this is a really popular thing in the space community, which is why they're launching this Runway to Jupiter style challenge in honor of Europa Clipper. What is this challenge and how can people participate?
Yeah, so the challenge for anybody that goes onto social media often, they know that there's trends and there's challenges that people just do on social media. So NASA's doing their own style challenge. And what it is in order to kind of inspire people and get people in the spirit of the Europa Clipper launch, they want people to express their creativity through style. So it could be through makeup, accessories, clothes, your nails, whatever it is, you can bring in different elements. It's not just the colors, right, of Jupiter and Europa that are different ways that you can bring in these elements into your style, but it's also like the features of Jupiter and Europa, the icy kind of like ragged surface of Europa and the flowy atmosphere of Jupiter. You can bring that into your style. You can bring the weather conditions. It's really cold. So how can you do that? And it's just a really, really fun way to be able to bridge that art in with this launch. And that's something that I really love to do. I love to find different ways to bridge the two together. So this is just a really fun challenge. And there's different ways for people to participate. The best way is to probably go on their website. They have a really great creative brief, basically just letting people know exactly the colors and a mood board to kind of get you inspired. But yeah, it's a super simple challenge. All you have to do is use your creativity and see what you can build.
And then how do people actually submit their images?
Yeah, so you do this through social media, any social media platform. And by doing the hashtag Runway to Jupiter, NASA can find it. So once you do that hashtag, you're kind of like just included with all these other submissions, and you have the opportunity. NASA might share your image on their social media channels, or even during the Europa Clipper launch kind of program, they might even share it there. So it's just a really cool, fun way to get in the spirit of the Europa Clipper launch.
Well, whenever I think of space-inspired outfits, I always think of you, because I know on your social media you like to share these videos of you like dressing up as certain moons and that kind of thing. So I know that you made one for this occasion. What was your take on this runway challenge?
Yeah, so I looked for some of my favorite images of Europa and Jupiter, and I found 3 of each. And what I did is I personally took the colors and I looked at my wardrobe. One thing that NASA does encourage people, which I think is really great, is using what you have, right? Instead of going out and buying things, one of the best things that you can do to be creative is look at what you have and how can you create these looks. Luckily for me, my wardrobe is mostly fall colors, and Europa and Jupiter both kind of give fall vibes, like the autumn vibes. So it was fairly easy for me to do it. But, I just brought the main colors in from Jupiter and Europa, and I incorporated different pieces, skirts and shirts, and if I had a jacket or a belt, and it was really fun. I really enjoy figuring out outfits according to planets and moons and even spacecraft.
Yeah, this is a nerdy thing for me to say. Not that everything out of my mouth isn't nerdy, but I like designing space press-on nails. That way I can reuse them for other things. So I've got like a whole JWST series of them, but I was thinking of trying to replicate those cracks on Europa because I feel like that's a really cool texture.
Oh, yeah, for sure. And I have to say, you are one of the most creative people that I know. You're really good at just like, even your glasses, if you've never seen Sarah in person, she always has like fun glasses on, and your jewelry and everything else. You're just very, very creative. So I have to see these press-on nails because that sounds so fun. I don't know if I have the art capabilities to be able to draw something like that, but that sounds like something that would be fun to experiment with.
Well, I'm very lucky. My mom was an art teacher for a long time, so I learned from her wonderful painting skills. But I also like to do something where, sometimes it's really hard to kind of convey the complexity of like a space look and just makeup. So sometimes I use face painting to try to get those like finer details. So I was thinking before the Europa Clipper launch, it'd be really cool to like, I don't know, just practice around with maybe some Jupiter swirls or something Europa inspired. But we'll see. I'll pull out all my glitters and my paints this weekend.
Yeah, that's so fun. Yeah, as I mentioned on the NASA website, they really encourage the different colors. They have like the palettes that you can use, and there's a lot of metallics and shimmeries and stuff like that. So I wish I knew makeup more because that would be really, really fun. So if you do it, I'm very excited to see what you create.
I'll take a whole bunch of pictures and share them and participate because I feel like, we've been waiting for this mission for so long, and the people working on this spacecraft have dedicated decades of their lives to it. And were it me working on that mission, I think it would mean a lot to me to see how much it's inspired people just to be there and to love this thing, but also to go that extra step and dress up and celebrate because, come on, this is something we've been working to as a species for ages.
A lot of people, the reason they get into these things is because they want to inspire people. So to see people kind of like emulate that into their own creativity is really beautiful to see. And, I've seen a couple images where people have crocheted their own outfits with kind of a little bit of a Europa or Jupiter. Yeah, it's beautiful to see when people get excited because this is such an amazing, groundbreaking mission that we're about to embark on. And if anything, if people don't know what it is, if they see you and they're like, hey, why are you wearing these colors? Why are you wearing this thing? It sparks a conversation. And that's kind of what NASA wants to do as well, I'm assuming, with this challenge, is if people don't know what Europa Clipper is, it's an opportunity to spark a conversation about how humans are trying to find themselves in the solar system. And it's just so beautiful. So I love this challenge. It was a great idea by NASA. And I keep checking the hashtag to see what other people have uploaded because it's just fun to see.
Yeah, well, if anybody listening participates, we're going to be looking online at this hashtag, but also feel free to put those images in our member community if you're a Planetary Society member, or you can just straight email them to us at our Planetary Radio email. We'd love to share them on the website for the Europa Clipper launch, because this is just, it's a really cool and fun moment. So what is the deadline for submission on this challenge?
Yeah, so it's launch day for Europa Clipper, which is October 10th. So get your outfits together, your jewelry together, put it all together, get it on social media before October 10th, and possibly NASA might share it.
Well, thanks so much, Amber. I'm looking forward to seeing your video online, and I'll share all my images when I'm done doing my crazy look.
I'm so excited. I look forward to it. Thank you, Sarah, for having me.
Before we move on to what's up, I want to give everyone a heads up that there's currently an opportunity to observe C2023A3. That's Comet to Shinshan Atlas. We forgot to mention it in What's Up, so I'm going to add the Planetary Society's new article on how you can catch that comet on the show page for this episode. And now it's time for What's Up with Dr. Bruce Betts, our chief scientist at the Planetary Society. He'll have more on the possible meteor shower created by the DART impact. Hey, Bruce!
Hey, Sarah!
How you doing?
Oh, spiffy, keen, wonderful, hunky-dory, swell, I don't know.
I don't know. I'm anytime we're in one of those months where it's like a bunch of space missions that I really care about are all going up, it's that tension in the air, but also that excitement, you know?
Yes, I do know.
So many of our board members and our team members are going to be at the Europa Clipper launch. But in the meantime, by the time people are listening to this episode, we're going to be right out just a couple days from the launch of this Hera mission that we've been talking about. And the DART, the Double Asteroid Redirection Test DART mission was my first rocket launch. So I'm hoping the second rocket launch of this kind of saga does really well.
Yeah, we're all hoping that for Europa Clipper and Hera. They're good. They're good stuff.
I've spoken to so many people that have worked on this entire, mission arc, both from the United States and from Europe. And we always knew that we hit Dimorphos really, really, really hard. But the fact that we hit it so hard that there might actually be the first human-caused meteor shower in history is a little bonkers to me. I know that you're a little skeptical whether or not we'll see it, but at the same time, that's a cool idea.
Yeah, it is. And I'm skeptical of everything, so you always have to take that into account. It's that scientist crankiness.
Are you saying I should be skeptical of your skepticism?
Yes. Strangely, I guess I was saying that. Wow, the layers of skepticalicity are just incredible. Oh, that'll be an album name.
Skepticalicity.
Okay, I'm getting distracted. Yes, that is quite fascinating that we might cause the first human-caused meteor shower. Now, we have caused plenty of stuff to re-enter the atmosphere as artificial meteors, but this would be the first time we have rocky stuff that we blasted off something to do that, at least as far as I know. Can't think what else it would be. Yeah, so apparently, look says we might get a meteor shower in 2034.
Where and when do you think we might be able to see it, if we actually get to see it?
If it's visible, well, if it happens, then it's mostly in the southern hemisphere. It's a good southern hemisphere thing hitting that part of the planet. And the prediction is you'd have mostly small stuff, but you might have things as big as the size of a softball, which would cause one heck of a bright meteor, but then not make it to the surface, presumably.
I remember when I was a child, I was watching the Geminid meteor shower, and there was a meteor that was so bright, it streaked across the sky, and it literally kind of temporarily burnt my retina. All I could see was that streak through my vision.
That's so cool.
That's what I'm imagining here. Something the size of a softball.
I've never had my retina burned by a meteor. I've tried so many times.
Just got to watch more of them. You got to be there in the Southern Hemisphere in May 2034 is what's up.
That's a fireball.
It was so cool, man. And I've seen some cool bolide explosions, things like that. But I mean, to be clear, on average, you're not getting softball size objects during meteor showers, right? I mean, it can happen, but what is the average size of these objects?
Typical is kind of sand size, dust size, even dust sand, maybe up to the size of a pea to use our standard vegetable measuring system.
Are there any other meteor showers in May that people should be aware of? I don't want people to confuse these two things because it feels like it would be really special to know.
Well, I've got a few years to work it out. Yes, the Eta Aquarids, which I try to make sure I pronounced all these perfectly, is a pretty strong shower for, interestingly, the Southern Hemisphere. So that usually peaks in very early May, kind of 4th, 5th type time. I mean, it's kind of an average-ish. I said strong, but it's kind of average-ish. So maybe 10 to 30 meteors per hour from a dark site. So I'm not sure what they were predicting with this or if they made a prediction.
I love meteor showers. It's probably just, just my childhood time. But I imagine as we get better at planetary defense, there's going to be more and more of these human-caused meteor showers, and we'll have even more to look forward to. That and all of the satellites crashing into our atmosphere to someday.
Well, yeah, that's starting, and thanks to certain groups, there are lots more that will be crashing into the atmosphere. They make some very nice meteors.
Well, you and me, Bruce, Southern Hemisphere 2034, let's go.
Road trip.
That would be wonderful. I gotta hit every continent on Earth before I kick the bucket. So I feel like most of the reason I'll end up in other countries to plan out my life plans is around these cool space events.
Well, I'm sure everyone wants to know, how many have you taken down so far?
I've been to every continent except for South America and Antarctica.
Oh, well, you're good.
Yeah, no, I'm making pretty good progress. I just, I gotta get down there, visit Brazil or something, and then head on down to Antarctica and look for some meteorites or something.
Ooh, that would be cold.
It'd be cold, but totally worth it.
Worth it. Yeah, that'd be neat. If you're interested, I've got a little bit of a fact for you. In fact, it's a random space fact. Did I surprise you?
So surprised. Didn't see it coming.
So Hera and DART, DART in the past and Hera in the future, are visiting the system with Didymos and Dimorphos. Dimorphos is the one that the asteroid impacted by DART and causing this future meteor shower. And Dimorphos is also the smallest asteroid that we have visited with a spacecraft. And it's about the length of the height of the Great Pyramid of Giza.
Wow.
About 150 meters ish. So yeah, I mean, it's not shaped like a pyramid. It's shaped like a potato with cornflakes on it, which is a pretty standard description in the technical literature, I'm sure.
That's a good way to think about it, though. In my travels of the world, I've been to see the Great Pyramids in Egypt, so that does actually give me a good mental image, and that's pretty small. Well, knowing your passion for identifying places around the world, I know you do like to do a lot of international trivia of that sort. So
I do, and I'm a little behind, but I'm a big fan of GeoGuessr and figuring out where you are when you plop down in a Google Street View and figuring out where you are from the clues.
Just in case you ever fall out of orbit and need to immediately figure out where you are based on context clues.
Exactly.
Right?
It's
you
important.
Never know.
Hey, it actually comes up. You'll see pictures on the news or something, and you're like, "Oh, wait, look at that crosswalk sign. It's got eight stripes. That must be from Spain. We're going to hear about Spain." It's that practical kind of information that you learn.
One of these days, people will have to have a GeoGuessr for, Mars or something. People in this crater love to use 5 stripes in order to signify danger, but people over here in the canyon system, man, they're all about, pentagons.
I mean, you could do it now. It'd be a lot of red dirt and rocks, but we really haven't been that many places on the ground. So
it's true. I can tell by this sort of tracks that this is Jezero Crater versus Gale Crater.
Look, it's dragging a wheel. Spirit.
That's awesome. We need to make this right now. I would play that.
I would too. Hey, everybody. Go out there, look up the night sky, and think about how many stripes you would put on your crosswalk sign. Yeah? Yeah, sure. Thank you, and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with the Planetary Society team as we update you on how the Hera launch went and take a moment to reflect on the role the Planetary Society and space advocates have played in supporting the Europa Clipper mission. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review or a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email at planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. I would love to see your Europa Clipper or Hera-themed outfits. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our asteroid-loving members. You can join us and help support missions like Hera and Europa Clipper at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. And until next week, Ad Astra.